Hey everyone, and welcome back for another deep dive.
Excited to be here.
Today we're diving into the world of software engineering
Yeah.
and system design
System design.
with this really interesting document
Yeah, it's a cool one.
called ByteByteGo Big Archive System Design 2023.etf,
That's it.
which is kind of a mouthful, but
It is.
that's basically a collection of excerpts
Yeah.
and illustrations and cheat sheets
All sorts of things. Yeah.
and visual guides on just all sorts of computer science
Yeah.
and software engineering concepts.
It's really cool because it's designed to give like a really strong
Yeah,
understanding of core concepts and trends
exactly.
in software development.
Whether you're prepping for like a tech interview or you're just curious about how things work.
Or even thinking about switching careers.
Yeah. Or if you're like me and you just like to
Yeah.
geek out on this stuff.
Totally.
Let's start with the building blocks
Okay.
of software development,
Yeah.
which is programming languages.
Force.
But how do those languages actually work?
Right.
This document breaks down the difference between
Yeah.
compiled versus interpreted languages.
It's a fundamental difference in
Yeah.
how these languages function.
So it's like, imagine you have this recipe
Okay.
that you want to share with someone
Right.
who speaks a different language with compiled languages,
Yeah.
which are things like C, C++, plus A, and Go.
Go.
It's kind of like translating that entire recipe
Okay.
beforehand
Right.
into the other language.
Right.
So
Yeah.
then when you give it to them, they can just like read it and follow the steps.
It's executed immediately.
And it's super fast
Right.
because the computer can understand those instructions directly.
Yeah. It's been translated into like machine code
Yeah,
that
exactly.
the computer can then directly execute.
It's like having a perfectly translated instruction manual
Exactly.
ready to go.
Yep.
But then what about interpreted languages?
Okay. So interpreted languages,
The document mentions Python, JavaScript, and Ruby
all the popular ones these days.
as examples. So
Yeah.
it's kind of like you have...
It's like you have a real-time translator
Yes.
working alongside the computer as the code is executed.
Yeah, so like line by line, someone's translating it,
Exactly.
which can be more flexible, right?
Yeah, because you can kind of change things on the fly,
Yeah.
but it might be a little slower.
Because of that extra step.
Yeah, you got that middleman in there
Yeah.
doing the translation.
So it's like that
Interpretation.
trade-off between speed and
Yeah.
flexibility.
Yeah, exactly.
Now, when we talk about software talking to each other,
Okay.
we can't forget about the internet.
Of course not. The internet's everywhere.
Yeah.
How does all this stuff communicate?
Right.
How do websites talk to each other?
And this document has this really cool
It does.
one diagram breakdown
Yeah.
of how information flows online
Right.
through these various network protocols. It's like a roadmap of the internet.
It really is. It shows all the different ways that
Yeah.
information can be transmitted.
It's like, wow, this is how this stuff works.
Yeah, it's like the underlying infrastructure that makes the internet possible.
And understanding these protocols like HTTP,
There's HTTPS, TCP, UDP,
TCP.
all these acronyms. Right, that you hear about all the time. But
Yeah.
it's like, what are they actually doing?
Yeah, exactly. And once you understand that, it's like, oh, that's how everything
It all clicks.
Yeah.
You're like, oh, that's how my web browser is talking to this server,
Yeah.
and that's how I'm getting this information.
Yeah, it all makes sense.
It all comes together.
It's like, imagine sending a postcard.
Okay.
HTTP is like the basic postal service.
Yeah, like getting it from point A to point B.
Right.
That's HTTP.
But HTTPS
HTTPS.
is like adding that secure envelope.
Right, it's like encryption.
Yeah. So it's like
Encryption.
no one can
Yeah, no one can tamper with it.
Yeah.
No one can read it along the way.
read it along the way.
It's secure.
And TCP and UDP
I
are
know,
like
right,
different
yeah.
delivery methods.
Yeah, they're like different ways of packaging that information
Yeah.
and sending it across the network.
So TCP is like, you need to make sure that every piece of this
Right.
arrives in order.
It's like a guaranteed delivery.
Yeah. It's like,
Yeah.
I need to send this package
Right.
and it all has to be there.
It's like sending a book.
Exactly.
You want all the pages to arrive in the right order.
Whereas UDP is like,
It's like a quick text message.
yeah, exactly.
It's like, I just need to get this information out there quickly.
I don't care if a word or two is missing.
Exactly.
It's like, just get it there fast.
Yeah, prioritize speed over reliability.
Yeah.
Sometimes that's what you need,
Exactly.
especially if you're doing something like streaming video.
Yeah. Okay. Now let's talk about API security.
All right, API security.
The document dives right into these
Yeah.
12 tips
Tim Tord.
for keeping APIs secure.
It really is, because APIs are kind of like the doors
Yes.
through which different applications communicate.
And we need to make sure that those doors are locked
Absolutely.
and only the right people have the keys.
Yeah, you don't want just anyone walking in and accessing sensitive data.
So that leads us to authentication methods,
Okay, authentication.
which is like,
How do you prove who you are?
yeah, how do we know it's really you?
Right.
The document talks about cookies and sessions and JWT,
All these different ways of verifying identity.
which honestly sounded kind of intimidating
Yeah, it can be a bit jargony,
at first.
but it's actually not that complicated.
Yeah. Okay, so let's break it down.
All right, let's do it.
What are cookies?
Okay, so cookies are like those little loyalty cards
Yeah.
you get at your favorite coffee shop.
Okay.
They store information on your device
Yeah.
to remember things like your preferences or your login details.
So it's like when a website says,
Right.
welcome back your
yeah,
name.
exactly.
It's using a cookie to remember me.
That's how they do it.
It's pretty cool.
Yeah, it's a handy little mechanism.
Okay, so then what's a session?
All right, so a session is more like a temporary ID card
Okay.
that the server gives you while you're actively browsing.
Uh-huh.
So think of it like checking into a hotel.
Okay.
You get a key card that grants you access to certain areas,
Right.
but it expires when you check out.
Okay, so it's like
Right.
for that specific visit.
Yeah, exactly. A temporary credential.
Okay, that makes sense.
And then we have JWT,
JSON Web Token,
JSON Web Token.
which sounds very complicated.
It sounds complicated, but the document uses this really great analogy.
Yeah.
It's like imagine a message inside a box
Okay.
sealed with a tamper-proof signature.
Right.
That message contains your authentication information,
Uh-huh.
and the signature makes sure that it's genuine and it hasn't been altered.
So it's like super secure.
It's super secure.
Yeah.
That's why it's often used for like sensitive communication,
Okay. In different parts of an application.
and it's becoming more and more popular.
It is.
Yeah.
It's a really robust way.
Now here's a stat from this section that really made me think.
Right, me.
The developer to tester ratio
Oh, yeah.
has shifted from 1 to 1
Wow.
to 100 to 1,
That's a big shift.
which is a huge shift.
That means for every 100 developers, there's only one tester.
It makes you wonder about quality control.
It really does.
It's like having 100 chefs in a kitchen,
Right.
but only one person tasting the dishes.
Before they go out to the customers,
Exactly.
you got to wonder how much is slipping through the cracks.
Yeah. How do we adapt our testing processes
That's the big
to
question.
keep up with this shift?
Right, because the landscape is changing.
Yeah.
Development teams are getting bigger.
And the pace of development is getting faster.
So how do we ensure quality?
Yeah. How do we make sure that things aren't breaking left and right?
Exactly, because nobody wants buggy software.
Yeah.
And this leads us perfectly into the next section of the document,
Okay, what's next?
which is all about software architecture.
Software architectures.
Yeah, like the blueprints
So blueprints for building applications.
for how to build applications.
Uh-huh.
I'll admit,
Yeah.
this is where I get lost sometimes.
It can be confusing,
Yeah.
all those acronyms.
Yeah, like MVC and MVP and
MVVM.
MVVM.
That's a lot to keep track of.
Yeah. But the document does a really good job
It does
of
it.
demystifying these concepts.
Breaking it down.
So what is MVC?
Okay, so MVC stands for Model View Controller.
Okay.
It's kind of like a classic, well-structured building.
All right.
You've got your data, which is the model.
Okay.
You have the user interface, which is the view.
Uh-huh.
And then you have the controller, which is kind of like the brains of the operation.
Managing everything?
Exactly. Controlling the flow of information.
So it's like separating those different
Yeah.
concerns.
Keeping things organized
Yeah.
so it's easy to understand and maintain.
So MVC is like a well-organized skyscraper
Yeah, I like that analogy.
with each floor
Right.
serving a specific purpose.
Each floor has its own function.
So then what about MVP and MVVM?
Okay, so MVP stands for Model View Presenter.
Okay.
And it's a little bit different.
Yeah.
The presenter kind of acts as an intermediary between the model and the view.
Okay.
So it's like a more modern building
Right.
with a central control system
Yeah.
that manages the flow of information.
And then MVVM.
MVVM is Model View Model.
Model view model.
And it's even more modern.
Okay.
It's like a building with smart sensors and
Uh-huh.
automation, where the view and the model can interact more directly.
So they're like talking to each other?
Yeah, they're more tightly coupled,
Okay.
but it's still a well-defined architecture.
So it's like choosing the right building structure
Exactly.
based on what you're trying to build.
You wouldn't use the same architecture for a skyscraper as you would for a small house.
Exactly.
You got to pick the right tool for the job.
And that leads us to design patterns.
Okay. Design patterns.
which the document highlights as like reusable solutions.
Yeah, they're like pre-designed solutions
Yeah.
to common problems.
Yeah, it's like imagine you have this toolbox
I love that analogy.
filled with
Yeah.
pre-designed solutions
Right.
for recurring problems.
Yeah, so you don't have to reinvent the wheel every time.
You just pull out the right tool
Exactly.
and apply it to your situation.
And it saves you a ton of time and effort.
It's like having a set of Lego instructions
I love like
for building specific structures.
Yeah, it's like you don't have to figure out how to build a house from scratch.
You just follow the instructions.
You have the blueprint right there.
Yeah. And speaking of building things, well,
Okay.
the document emphasizes the importance
Yeah.
of solid principles.
Solid principles.
And KISS. Keep
Sure,
it simple,
Be
stupid.
simple, stupid. Yeah, it's a classic principle.
Yeah.
And it's so important in software development.
So what are solid principles?
So solid principles are basically like guidelines
Okay.
for creating well-structured, maintainable code.
So your code isn't a complete mess.
Right, because nobody wants to work with spaghetti code.
Nobody wants to untangle that.
It's a nightmare.
So it's like a building with a
Okay.
strong foundation,
Yeah.
clear pathways,
Right.
and easy access for maintenance.
Yeah, you can easily go in and fix things
Yeah.
without breaking everything else.
And KISS reminds us that,
KISS is all about simplicity.
yeah,
Don't overcomplicate things.
so our engineer.
Yeah, because the more complex your code is,
Yeah.
the harder it is to understand.
And the harder it is to maintain.
Exactly, and the more likely it is to have bugs.
It's like trying to build a house with too many rooms and hallways.
You'll just get lost.
You just get lost.
And nobody wants to live in a house like that.
All right, so we've got our building blocks.
Okay.
We've got our security measures in place.
Uh-huh.
We've got our blueprints.
Right.
Now let's talk about a trend
Okay.
that's reshaping
Yeah.
the entire software landscape.
I'm intrigued.
Microservices.
Microservices.
This is like building a city
Okay.
instead of one giant skyscraper.
I like that.
Yeah. So each service is like a self-contained unit
Right.
with the specific function.
So it does one thing.
Yeah.
And it does it well.
And it can be developed and
yeah.
deployed independently.
So you can update one service
Yeah.
without having to redeploy the entire application.
Which is super powerful.
It is.
That allows you to move much faster
And it makes your application more resilient.
and be more agile.
Exactly.
And this document lays out
Yeah.
these 9 best practices
Giant best practice.
for developing microservices.
It's like a checklist
Yeah.
for building a well-functioning city.
Exactly.
Make sure all the services are playing nicely together.
Make sure the garbage is getting picked up.
Right.
Make sure the electricity is working.
All the essential services.
But here's where it gets interesting.
Okay.
There's this case study
Right.
about Amazon Prime Video's monitoring system,
Uh-huh.
and they actually moved away from
Wow.
a microservices architecture.
So they went the other way.
They went the other way,
Interesting.
which was really surprising.
Yeah, it challenges the assumption
Yeah.
that microservices are always the answer.
Yeah.
Sometimes a simpler approach
Yeah.
can be more effective.
So they found that like
All right.
a monolithic architecture
Yeah.
where everything's
Where it's all together.
integrated into this single unit
Right.
was actually more cost-effective
Yeah.
and efficient
For their specific needs.
for their specific needs.
Sometimes it's not about being trendy.
Yeah.
It's about finding what actually works.
It's like realizing that sometimes a single,
Right.
well-organized building
Yeah.
is better than a sprawling city.
It depends on what you're trying to achieve
Yeah.
and how big your project is.
Exactly.
If you're just building a small website,
You don't need a city.
you don't need a microservices architecture. You
Right.
can just keep it all together.
Now let's talk about databases
All right. Databases,
and data management.
the heart of many applications.
Yeah. How do we store all this information?
Right, because data is everything these days.
And retrieve it
yeah, you got to be able to access it quickly and efficiently.
and process it.
Exactly.
This document breaks down all the different database types
Yeah,
in a really easy to understand way.
it makes it clear.
So first we have relational databases,
Okay, relational databases.
which are like
yeah,
organized spreadsheets
think rows and columns.
with rows and columns.
Structured data.
Yeah.
That's where relational databases shine.
So if you need to store
Yeah.
like customer information
hmm
or product information,
That's perfect for a relational database.
a relational database is a good way to go.
Yeah, because you can easily query that data
Yeah.
and find the information you need.
And then we have NoSQL databases, which offer more flexibility.
Yeah, NoSQL is all about flexibility and
Yeah.
scalability.
Yeah, and they're better suited
Right.
for like unstructured data.
Yeah, like social media posts
Yeah.
or sensor readings.
Things that
don't fit neatly
into rows and
into
columns.
those rows and columns.
Right.
So it's like choosing the right storage system
Exactly.
for your information.
Yeah.
Like, do you need a neat filing cabinet?
Right.
Or do you need like a flexible...
Or big storage bin.
Yeah, a big storage
Where
bin.
you can just throw things in.
And then be able to search through it.
Right.
Oh, and did you know that PostgreSQL is the most loved database by developers,
I did hear that.
according to this document?
And it's for good reason.
Yeah.
It's super versatile.
Yeah.
It can handle so many different tasks.
Yeah.
It's like the Swiss Army knife. Yeah, it can power simple web apps,
Right.
but it can also manage
Yeah.
complex data warehousing.
Huge amounts of data.
Yeah.
It can handle it all.
Versatility is key.
Definitely.
Okay, now let's talk about database sharding,
All right. Sharding.
which is a crucial technique
Yeah.
for handling huge amounts of data.
Massive amounts of data. It's like
Terabytes, petabytes.
splitting a giant library
So,
into multiple smaller libraries to
Right.
make it easier to manage
the information.
and access the information.
Exactly.
So imagine you have this massive library
Okay.
with millions of books.
Millions of books.
Sharding lets you divide those books
Right.
into smaller,
More manageable.
more
ones.
manageable collections
Okay.
based on certain criteria.
Yeah, so you could divide them by genre or by author.
Or by the first letter of the title.
Right.
Whatever makes sense.
Whatever makes sense for your application.
And this makes searching
And retrieving information
so much faster.
much faster.
Because you don't have to search through the
Yeah.
entire library.
You know where to look.
You go straight to the right shelf.
Exactly.
And you find what you need.
The document uses these simple analogies.
Yeah.
Like organizing books on shelves
It's a great way to visualize it.
or sorting playing cards
Right.
to illustrate
Yeah.
different sharding strategies.
Because it can be a complex topic.
And that is where we'll wrap
That's
up
great,
part
yeah.
1 of our deep dive.
Looking forward to part 2.
Me too.
So we've talked about building blocks and architectures and databases, but how do we actually deploy and manage these applications in the real world?
That's where cloud computing comes in, right?
Exactly. And this document does a great job of explaining its evolution.
It's like climbing a ladder.
Okay. I like that.
You start with traditional infrastructure
Right.
where you have to manage all the hardware yourself.
Yeah. You're responsible for everything.
The servers,
The network,
the
the
cooling,
power.
the whole shebang.
It's a lot to handle.
Then we move up to IA,
Infrastructure as a service.
infrastructure as a service.
Which is basically like renting servers and storage space in the cloud.
So you don't have to worry about
Yeah, someone else is taking care of all that infrastructure.
all the physical stuff.
Exactly.
And you can just focus on your applications.
Right. You just get the computing power and storage that you need.
It's like going from owning a car
Okay.
to using a ride-sharing service.
You don't have to worry about maintenance or insurance.
Okay.
You just pay for the ride.
And then the next rung on the ladder
Right.
is pay us.
Platform as a service,
Platform as a service.
which takes it a step further.
Yeah.
Cloud providers offer more pre-built tools and services.
So it's like going from
Yeah.
building a house from scratch
Right.
to having a prefabricated structure
That you can customize.
that you can customize.
So you still have flexibility,
Yeah.
but you don't have to start from zero.
You don't have to lay the foundation.
Exactly.
You don't have to frame the walls.
You can just focus on the interior design.
It's like a meal kit.
Okay, I like
You
it.
get all the ingredients
Pre-portioned?
and you just have to cook it.
You just have to assemble it.
Exactly.
But what about this cloud native approach?
Cloud native.
The document mentions that.
It's a hot topic these days.
It sounds very buzzwordy.
It does, but it's actually a really important concept.
So what is it?
Cloud native is about designing and building applications
Okay.
that are specifically optimized for cloud environments.
So taking advantage of
Yeah.
all the benefits of the cloud.
The scalability, the flexibility, the resilience.
It's like building a house.
Uh,
It's designed to adapt to the environment
I like that analogy.
with features like solar panels, rainwater harvesting,
Right.
and earthquake-resistant foundations.
It's built to withstand anything.
And I remember the document mentioned CI/CD.
Continuous integration, continuous deployment, continuous integration, continuous deployment.
That's a mouthful.
It is, but it's such a key part of
Oh,
this
and-
cloud native world.
Absolutely.
So what is it?
Think of it like an automated assembly line
Okay.
for software development.
So developers are constantly
Yeah.
adding new features and improvements to the code.
And CI/CD automates the process
Yeah.
of testing and deploying those changes.
So it's like having robots on the assembly line
Exactly.
could automatically check the quality
Well-
of each component
And they assemble the final product.
and make sure that everything is working properly.
Yeah, and then they ship it out to the users.
So it's like seamless and efficient.
It's all about speed and reliability.
And this document even has a cheat sheet
Oh, nice.
highlighting all the popular cloud services,
It's like a who's who of cloud providers.
like AWS, Azure, Google Cloud.
Alibaba Cloud.
All the big names are there.
They're all competing
Yeah.
to offer the best services.
Culinary choices.
It can be overwhelming.
Yeah. But it's also really exciting.
It is, because it means that we have so many options
Yeah.
for building and deploying amazing applications.
Now, I want to talk about the case studies.
Oh, yeah. The case studies are fascinating.
Did you see the one about levels.fi?
The website that used Google Sheets as its backend?
I know. Can you believe that?
It's incredible.
Like they built a skyscraper
Right.
on top of a spreadsheet?
It just shows you that
Yeah.
sometimes the simplest solutions...
Be most effective.
Exactly.
And then there's Discord,
Discord.
which had to scale its messaging system.
To handle trillions of messages.
Trillions.
It's mind-boggling.
It's like the Library of Congress,
but bigger.
but for messages. And they had to go through all
Yeah.
these iterations.
Different database technologies.
Yeah. They started with MongoDB.
Uh-huh.
Then they moved to Cassandra.
And then finally to SilidyDB.
It's like they were constantly...
Yeah, they were always looking for the best solution to meet their growing needs.
Because as systems grow,
Right.
what worked initially
Might not work forever.
might not cut it anymore.
You have to adapt and evolve.
Speaking of adapting and growing,
Okay.
let's talk about technical interviews,
The dreaded technical interviews.
which I know a lot of listeners are probably thinking about.
That's a rite of passage.
It is, but it can be nerve-wracking.
It can be, but this document has you covered.
Yeah, it's like a toolkit
A survival guide.
for acing those interviews.
They have recommendations for everything.
They have LEET code.
Lead code for practicing coding challenges.
Yeah.
Cracking the coding interview.
Cracking the coding interview, the classic
Must-read.
system design interview.
For all those system design questions.
It's a goldmine of information.
It really is.
And they even touch upon OP,
Object-oriented programming.
object-oriented programming.
One of the fundamental concepts.
I'm building with Lego bricks.
I knew you were going to say Lego.
You create these reusable blocks of code.
Called objects.
It's called objects.
Each object has its own properties and behaviors.
And you can combine them in different ways
It's like Lego.
to build different structures.
Exactly.
So OP is all about modularity and reusability.
It makes code more organized and easier to maintain.
But the document even breaks down
Yeah.
the different types of technical interviews.
It's like a cheat sheet. You might encounter...
But not all interviews are created equal.
So you might have coding challenges,
Uh-huh.
system design questions,
Behavioral questions.
behavioral questions, even OOP-specific assessments.
It's amazing how this document
It's a comprehensive guide.
equips listeners
Yeah.
with both theoretical knowledge
Correct.
and practical advice.
It's not just about concepts.
Yeah.
It's about how to apply those concepts.
In real-world scenarios.
Exactly.
It's like a bridge
I like that.
between theory and practice.
It connects the dots.
It's not just telling you what OOP is.
right.
It's telling you how to use it
In a job interview.
in a job interview.
That's what matters.
And I think it's really cool how this document
Yeah.
doesn't just focus on the
Yeah.
technical aspects.
It's not all about code.
Yeah. It also delves into
The human
the
side.
human side of software development.
Because software is ultimately built by people.
And for people,
Exactly.
it talks about the implications of that.
Yeah.
100-to-1 developer-to-tester ratio.
That huge shift.
Yeah.
It's changing the way we work.
Yeah. How do we ensure quality?
And how do we collaborate effectively?
Teams are getting bigger and bigger,
It's a challenge,
more distributed.
but it's also an opportunity.
Yeah. To rethink our processes.
And find new ways to work together.
So it's a great reminder
Yeah.
that software development
It's not just about code.
is about people
It's about people working together
working together
to create something valuable.
to create something valuable.
That's what makes it so rewarding.
It's amazing how this document brings together the human side and the technical side of software engineering.
Yeah, it shows that it's not just about the code.
It's about the people writing the code and the people using the software.
Exactly. Technology is a tool, but it's a tool created by people and used by people.
And that brings us to another key takeaway from this deep dive. Adaptability.
Oh, yeah. The tech world is constantly changing. What's hot today might be obsolete tomorrow.
So true. This document really stresses how important it is to keep learning, unlearning, and relearning.
It's all about being flexible and open to new ideas.
Yeah, whether you're a seasoned engineer or just starting out, you always got to be learning.
Absolutely. And that's what makes this field so exciting.
I know I'm walking away from this feeling super inspired.
Me too. It's like my brain is buzzing with new
And
ideas.
I've got a million tabs open in my browser.
I hear that it's like a rabbit hole of information.
So as we wrap up this deep dive, I want to leave you with a question.
Okay, hit me.
What's one thing you learned today that you'll apply to your own work or learning?
It could be a new coding technique, or a better understanding of system design, or maybe even a new way of thinking about problem solving.
Whatever it is, we hope this deep dive has sparked your curiosity and given you some valuable insights into the ever-changing world of software engineering.
Keep learning, keep exploring, keep building.
That's what it's all about. Thanks for joining us for this deep dive.
Until next time.